Hello there and welcome to this course on parallel data processing with Dask. Dask is a Python library that allows us to be able to execute code in parallel. So what that means is that it would split whether it's data that we have in the context of data analysis, the data that we are working with into just smaller chunks and be able to run whatever data preprocessing techniques that we have in parallel. So we would have, as a result, just less time when it comes to data analysis. So we can use this library Dask to work with big data. We can also use it to speed up the code that we have. We can also use it for machine learning if we have maybe a big data set that we want to use to train our model on. Then we can use this Dask library to be able to just speed up the entire process. So yeah, so that's it. That's what we're going to be learning, how to use the library itself. Our focus would be on the data analysis side of how to use this tool. So yeah, so let's get started. The first thing that you need to do is to visit the description link of this video and you'll get the practice resource that we're going to be using for our work today. So once you visit the description link, you get to this page, which will require that you just sign up. Once you sign in, just click on continue learning and you'll get to the sample notebook. If you're an Afterwork member, you will have access to the practice notebook once you've signed in. And yeah, so we can get started. I'll be using the practice notebook, but it's similar to the sample notebook. So just don't worry so much about that. It's just that the practice notebook has more challenges, but the examples are similar. Okay, so the first thing that we need to do is to import the Dask library, and in our focus would be on the data manipulation side of it. And we would import it as we would with other types of library or other libraries, but as you can see, we would need to install it first. So in a new code cell, which you can create by clicking on plus code, just need to write pip just install pip install Dask. That should do the work of just installation, and we can run it. All right, so once we've got that running, so we then decide to import the Dask library, but what we want to work with within the Dask library is the data frame module, and this will allow us to work with functions when it comes to the data frame. So Dask provides us with a data structure, just like pandas, that allows us to work with data. So we can preview data, we can handle missing values or outliers still the same way we would do with pandas, the same approaches, but the implementations of the functions that we would need for data analysis has been done in Dask. And to be able to work with those functions, we can use the Dask data frame module, and we import it data frame module, and we import it as DD. So you'll note that if we want, let's say, for example, to read a CSV, assuming this is our data set that contains traffic flow data, if we want to read it, we just use the read CSV function, which has been implemented in a way that looks similar to pandas for ease of learning, because many developers do not necessarily want to undertake now a learning journey that is inconsistent with the tools that they have been using. If it's how they have been using, say, something like pandas, they would rather be able to implement the technique that they want in a similar approach to what they've been doing in the past. So this is how we just are able to read the CSV. If this were a large data set, then we would read it in parallel. So it would divide it would split the data set or the task of just reading this data set into just different chunks and run it in parallel. So once we do that, we just preview the data set as we would. So the first 5 records, and this is just a Dask data frame. We call it a Dask data frame, not a pandas data frame. This is now in the context of Dask. In the past, maybe you might have also gotten to have gone through another video. We will be releasing more videos on how to work with large data, especially with the Python language. So you might also get to learn about working with another library that allows us to work with large data. That's called varx or varx. It depends on whatever you want. So that's one. There's also polars, but you'll realize the implementation is not so much different. It's only that those libraries, the approaches that they take would be slightly different from how these other libraries they would take, and they all have benefits and their own trade-offs. All right, so once we've previewed the data, we can also now decide to maybe perform some operation. Like if we wanted to calculate the mean of speed, we can apply the mean function just as we would in pandas, but now we apply a compute function after that to be able to perform this task in parallel, and the output will be stored in average speed variable, and we can print it out as shown. Okay, pause the video and then work on the challenges, on the challenge. Moving on, here we've just performed one particular arithmetic, well, not, it's an aggregate function, which is the mean. We can also perform other types of, we can apply other types of functions, such as being able to perform standard deviation. We can calculate the quartiles. We can calculate minimum and maximum just using the respective function. So assuming this is our data set again that we've loaded in parallel, we can decide to calculate summary statistics. So for instance, in our case here, we're just creating a variable, and that variable would contain a dictionary that contains key values. So here we have mean speed, and the value would be the calculation that we have here. So it would be this, for the speed column, we calculate the mean and we apply the compute function. To calculate the median speed, we can do the same thing, quartile 0.5, which, you know, actually intends to calculate the median speed. We can calculate the standard deviation, the 25th quartile, the 75th quartile as shown here. And we can, again, output our summary statistics. But you should note that we always apply the compute function to execute our code in parallel. Moving on, in some cases where we want to perform, we want to handle missing data, we first of all would need to say load the data. So assuming this is a data set that we have, it just contains healthcare and pharmaceuticals data, we might want to identify the missing values. We would apply the isNull and sum function just as we would in pandas, but now use the compute function to perform this technique in parallel. And, you know, print out those missing values from this Dask data frame. And you can see this is what we have. Age, there's 1, and income, there are 2. And we can decide to drop those missing values as shown. So for dropping, we just use the drop NA function that we are familiar with. And also for, again, we would, again, if we apply this, we would still need to display to perform that particular technique. So we can still apply the compute function at the end, but we can still apply it in a different variable and print that out. All right, so, and check for missing values again to just check for the missing values for our data frame. Okay, in some other situations, we might want to select columns, numerical columns. We can still do the same thing as we did, you know, pandas. We use the select dtypes function and specify the data type that we want, which want to be one that is of a number that would be either int or float, and apply .columns to get now the columns themselves that are numerical in nature, and we can print them out. Here we're just getting the list of those columns, and then we can pass them to the df data frame here, which will actually give us the entire data that is contained within those columns. But then we apply a mean to be able to calculate the mean of those columns, and we perform that operation using the compute function, well, in parallel, and we do this by specifying by using the compute function, And the mean of those particular columns, we actually use the values as the ones that we would want to replace for the missing values in the DF data frame. And then we can be able to display the computed, the data frame itself, which would contain now values without the missing values. It should contain records without the missing values, and then we can check for missing values as shown here. Right, pause the video and then work on the challenge. In some other situations, we might want to filter for data, especially when we have research questions that do not require the entire data set. So if we have this data that contains traffic flow data, we can specify the conditions just as we would. So here we have our first condition, DF color is equals to red. If we want to have a record that has DF color as red, as well as speed greater than 50. So those are the records that we want to get, and those are the conditions that we set, and then we pass them to the lock method, and we combine those conditions using the ampersand character, and that should give us now the filtered data frame. And again, we use the compute function to just be able to apply that, perform that process in parallel. And as you can see, we have records with red as the color, and have a greater speed of greater than 60. Pause the video and then work on the challenge. In some other situations, we might want to create summary tables. Again, we use the read CSV function from the Dask data frame, and we are able to see Dask data frame module, and we're able to see the data set, and we can use the group by function, which is also an implementation done to perform group by in Dask, and we would want to group this data by vehicle type and speed. So speed is this column over here. We want the mean of each vehicle type, and we apply the compute function at the end. That should give us the grouped data. Once we get the group data, we can store it in this variable. Then we can also group by this other particular column. So we also have this particular, we can group by weather as well, and accident is where is it on the far end, and we can compute that. I think this should be actually we can use just occupants instead of accident, and we can also group by direction, then speed as well. The same case, weather and speed as well. We can also do the same thing. Yeah, so I think you get the idea here. We are just creating some summary tables. So we are displaying the final one, which is this one that you see here. All right, moving on, we can also perform some custom aggregation. So if we want to perform an aggregation function that we would define, we can create a function that would contain that aggregation operation. Could be maybe whatever that we want. Here we are just specifying just one. We would want to use the data that we would get, which would be grouped data, and then we calculate the mean of that grouped data. That's for speed, and we pass it back. But again, to be able to apply this custom function to our grouped data, so we would just use the apply function and just pass the actual custom function, and we specify the actual calculation that we want. So actually, no, I've explained this a bit differently. So in our case here, where we are grouping by speed, so we actually grouping by vehicle type, and then we are calculating the mean of the speed. And we would need to specify the data that we are calculating for in this particular case. So this is speed, and we can define the data type as well. But again, just defining speed should be okay, and just then applying the compute function should give us what we want. Okay. Moving on, we can create new columns. So assuming that we have this data set that we would want to create a new column for. So just maybe if you want to create a new column in order to answer some research questions, So for example, this is the data that we have that contains traffic flow data. We can set an index just to be able to work with this data with ease. So we can set the vehicle ID to just have the index to be the index column, and then we can create a custom function that will create the new column. So this custom function will use the speed column, the data that we give, to be able to define a new value for a new column. So if the speed is greater than less than 50, we would have that new column's value as low, and the other values as shown here. So we just apply the custom function to the speed column, and we just also define the new column that we want to create. So speed category, and again we also have it here defined here at the very end, so that the values of this particular operation are stored in speed category, and we define also the object, not the object, we define the data type as well, and we apply the compute function to be able to perform this task in parallel, and we display the first few rows. Oh, I haven't run this, sorry. And it's important to also have this as an index without just working with the normal indexes, just to perform this particular operation. So you need to set your own index for that particular case. All right, moving on. In some cases, we might want to perform sorting. So we just use the sort values function, and we specify the column that we want to sort. And in ascending order or descending order, like from top to bottom as shown here, and then we can display the sorted data frame. So here we have sort values, the speed, then ascending. So ascending false. So ascending, so it's able to be in descending order. So the records are from 70 downwards to 55, etc. Right. In some cases, we might have research questions that require us to work with time series data. And if we want to maybe work with a specific time zone, then we can use the toDateTime function to convert, first of all, the data that we have. Say, for example, if we want to work with this data set and it has these two columns, we can convert those columns to have a datetime format using the toDateTime function, as you can see here. And then once we have the data in datetime format, we can then use the, again, tz localize function to first of all set to set the first time zone, or the regional time zone, which is the UTC time zone that we want. It just means that this data is in UTC, and we apply the tz convert function to do the same thing, and then we can actually initially we would localize the UTC, then we can convert now this particular existing original value to the specific time zone that we want. Here we want this time zone, Europe, London, and we store that new data. It's actually in the original column, and we can have, it's usually good practice to have another column here, but we just specified that we just want to replace the old value so that the new data has now the new target time zone, which would be this. And we do the same thing for exit time. All right, lastly, if we have already performed, let's say, data preprocessing, like what we have here, we can then just export that data maybe to a CSV format, or whatever other functions, or whatever other formats that you want. This might be CSV, it could be Excel, it could be SQL. So we just use the toCSV function, and that would generally be it. So if I load this data set, we just use toCSV function and specify the data set, and we don't want the index column, this column, to be in that data set, and want it to just be a single file. So if I go to the far left, if I click on here and then I run this code, the data should appear over here. So if I refresh this, I should be able to see the traffic flow data. All right, so that's it with regards to this course. It's one that helps you to just learn more about how to efficiently work with data or Python in general, and it just helps you to just think about maybe how you can use fewer resources when it comes to just running Python code. If you did love this learning experience, be sure to give it a thumbs up. And if you'd want to be informed when we post such future learning experiences, be sure to subscribe. All the best in your learning journey. Bye.